Assalamu alaikum everyone. My name is Memuna Astaq, and today the topic I am going to present is a review of a paper which is a mobile AI assistant for campus area network management. So before going into the depth of this topic, I would like to tell you about the structure of my presentation. It is categorized into three parts. The first is summary, the second is evaluation, and the third one is synthesis. In this first part, summary, I will describe these questions: that what is the research problem this paper attempts to address, what are the claimed contributions of the paper, and how do the author proves his claims, and what are the conclusions. And in this second phase, evaluation, it will address these questions: that is the research problem significant, are the contributions significant, and are the claims valid. And in this last section, synthesis, it will describe these questions: that what are the main problems raised by this work and how the research results can be improved. So let's begin with this first part, summary. As all of you know that campus area network interconnects multiple local area networks that are covering different departments and sectors in a university or a company. So the structure of any organization constantly changes, and to meet these changes, the network infrastructure needs to be managed in an efficient way. So virtual LAN is a key technology for efficiently managing the network. Virtual LAN dynamically configures the network by dividing it into multiple broadcast domains, and each broadcast domain has its own transmission range. In an organization, if there are two or more sections that are sharing a single switch, then two or more VLANs can be defined in that switch, and each VLAN segment acts as an independent network, because the data traffic in one VLAN segment does not interfere with the data traffic in another VLAN segment. So these are the benefits of VLAN, but on the other hand, it faces a serious problem for appropriately maintaining a VLAN network, because the reason is actual VLAN configuration is invisible from the physical network cabling. So augmented reality is a technology which makes the internal structures of objects to be visible entities. And augmented reality is used in different fields such as medicine, underground infrastructure visualization system, and civil engineering. And this proposed work, which is a hands-free VLAN maintenance system, is developed using augmented reality technology, which helps the administrators to visualize the VLAN configuration by obtaining the latest information on the fly, and activate some programs, and allows to perform maintenance operations in actual rooms. When an administrator simply looks at a specific switch device, the proposed system acquires the latest configuration information about the device and graphically superimposes the results. It makes the maintenance easy and efficient. The administrator can easily get the information for reconfiguring the device by X-raying the device with your line of sight and perform some maintenance procedures without using hands. So this was all about the summary. And now comes the second phase, evaluation. Usually the administrators spend enormous amounts of effort and time for the maintenance of a VLAN network, because they can't grasp the VLAN configuration by tracing cable connections. The proposed work is such that the system is running on a mobile notebook worn by an administrator, and then the administrator can perform actual maintenance tasks with his or her free hands in a machine room. All he needs is to wear a web camera for acquiring input images and a head-mounted display for viewing a visualized output. In a usual machine room, switches and routers are stored in dedicated racks, and each device has an attached AR marker that has a printed black and white graphic pattern. And each marker's pattern is different, and the system identifies a specific device by its graphics pattern. The administrator turns his or her head toward a target device and captures its attached marker by using the web camera. And if the camera direction is adjusted to the viewer's line of sight, he or she can easily indicate his or her observing device by simply facing it. And now let's talk about the working of this proposed system. The system, which maintains a database record for the IP addresses and the port array image, and the system can perform these following tasks. It detects the IP address, it requests the network configuration collecting server, and it displays the results. From this figure you can see that the system detects the IP address of the device from the marker's graphic pattern captured by the web camera, and then requests the network configuration collecting server to get the latest information of that device by the detected IP address. Because this network configuration collecting server periodically collects the network configuration information in layer 2 and layer 3 IP layer levels using SNMP protocols. And after that, and after requesting the server, the server replies the configuration information in an XML format to the system, and then the system presents the acquired information to the administrator through a head-mounted display. And then the administrator can observe some graphics data and port array image, a list of VLAN IDs, and IP address of the currently observing device. These are important items for the network management task. Each VLAN has a VLAN ID, which is a unique identifier, and the same colored ports in the array image belong to the same VLAN segment. The administrator can easily find the searching VLAN ID with its corresponding color. A VLAN segment can be configured over multiple switches by using the tagged VLAN compliant switch. The tagged VLAN compliant switch adds the tagged information in an Ethernet frame header and identifies its belonging VLAN segment frame by frame. And in this proposed work, pseudo eye tracking method is devised. Eye tracking is a technique which detects a user's eye movements and continuously tracks the point of gaze. This method assumes that the user directs his or her head along with his eyes toward a target object and draws his focus of attention to the center of the captured image by the web camera. The system renders the viewer's gazing area by a red square and the currently focused area by a green square. Traditional augmented reality systems superimpose data onto all markers captured in an input image at the same time. But this system only displays the configuration information of a switch whose marker is closest to the center of an input image. Because if the system superimposes the configuration information for all the markers detected in an input image, it makes the output complicated and confuses the user. And from here you can see that the red square shows the gazing area and the green square shows the currently focused area, and this black and white graphic patterns shows the AR markers. Defining or reconfiguring VLAN requires many steps to execute, such as checking the current configuration, finding target ports to manipulate, changing physical cabling, and verifying connection for new routes. The proposed system enables the administrators to simultaneously execute some steps. It makes usual maintenance tasks more efficient to solve this problem. A function is implemented to select and activate commonly used programs without typing keyboard or pointing or clicking icons by mouse based on the pseudo eye tracking method. The user can activate some frequently used commands for checking connections with switches, such as trace route, ping, move, on and off. The administrator uses his or her line of sight for selecting and activating a specific command in the same manner that he or she indicates a switch device for checking its configuration. And from here you can see that the user moves his or her head to capture the focused marker with the gazing area, that is the red square, and then the system invokes a menu and places it around the marker. Because the system scales the gazing area size to be the quadruple size of the marker, the user can easily catch the marker. Then he or she again moves his or her head to capture the target command to activate with the gazing area. And then the system expresses the selected command by enlarging its plate size. The system executes the selected command, and then the user can perform these operations freehand. When he or she selects either command, the system invokes the command with the IP address of the currently focused switch to verify the reachability from the mobile host to the switch. And then the result is displayed on the captured marker position in the gazing area. And then the effectiveness of the proposed system is verified by conducting an experiment proposed system is compared with the traditional manner using notebook computers to see the differences on efficiency for network management. The subjects were requested to change the initial network to the target configuration because the target uses 2 switches for configuring a single VLAN segment. The subjects needed to set up a tagged VLAN port on both switches and reconnect 2 PCs to different switches one by one. All subjects finished the task from about 3 to 6 minutes. Results show that the task with augmented reality was finished faster by using the augmented reality system. And some questions in a questionnaire were also asked as follows: that which method is better to perceive the current VLAN configuration, and which method is easier to use in the task, and which method is lighter in operational load. And 5 to 6 subjects indicated that augmented reality system was better than the traditional computers. So it's a better approach to perceive the VLAN configuration. And now comes the last section, synthesis. Many subjects acclaim the visualization of VLAN configuration by the colored port array image, and a few subjects, however, stated that perfectly matching the visualized port array image to the actual port on the device front panel may be better. Therefore, there is a need to further consider about the better layout for the visualization. An head-mounted display is heavy to bear for a prolonged period of time, and it makes the person lazy and inactive for controlling operations with their head movements. So, these are the problems raised by this work, and these results can be improved. The system can only visualize the VLAN configuration of a currently focused switch device designated by the user. There is need to enhance the visualization function for not only showing the focus device information but also presenting the broader information such as whole VLAN topology, including all switches and routes constituting a specific VLAN segment. And then the system must be evaluated to use by the on-site administrators for daily network maintenance tasks. Well, that's my presentation. I hope you like it. Feel free to ask questions. Thanks for watching.